Let's look at problem 23 from OpenStax College Physics, chapter 28. Suppose the speed of light were only 3,000 meters per second. A jet fighter moving toward a target on the ground at 800 meters per second shoots bullets, each having a muzzle velocity of 1,000 meters per second. What are the bullets' velocity relative to the target? And if the speed of light was this small, would you observe relativistic effects in everyday life? So let's write down our knowns and unknowns. We're dealing with several different velocities, and we have to label them carefully so that we don't mix them up. So the first velocity is the speed of light. So c is given as 3,000 meters per second only. And then a jet fighter is moving towards a target on the ground at 800 meters per second. So the 800 meters per second are the velocity of the jet with respect to the target. So I'm going to label that as v jet relative to the target, and that is 800 meters per second. Then the jet shoots bullets, and they have a muzzle velocity of 1,000 meters per second. The muzzle velocity is measured relative to the object that shoots the bullets. So in this case, it's the jet. So we have the velocity of the bullets relative to the jet is 1,000 meters per second. And we are looking for the velocity of the bullets relative to the target. So we want v bullets relative to the target. So if we were dealing with a classical situation, so if it's just the relative velocities, then we would have velocity of the bullets relative to the target would have to be velocity of the bullets relative to the jet plus velocity of the jet relative to the target. So our velocities would add like this. And if we were to solve this, VBJ is 1,000 and VJT is 800. So we would get 1,800 meters per second. Now relativistically, so I guess I should call this classically, we have a different equation. We have to take into account the fact that the velocities are close to the speed of speed of light. So velocity is VBJ. Again, we have to keep the same order of subscripts plus VJT divided by 1 plus VBJ VJT divided by c squared. So that would be 1,000 meters per second plus 800 meters per second divided by 1 plus 1,000 meters per second times 800 meters per second divided by 3,000 meters per second squared. And when we plug in the numbers, we end up with 1.65 kilometers per second. So this value compared to the classical value is different. So classically we had 1.8 kilometers per second, but relativistically we have 1.65 kilometers per second. So there is indeed a difference, and if the speed of light were indeed much smaller, we would notice these type of relativistic differences in our values for velocities and all the other physical quantities a lot more.